Okay. Good morning, guys. We're going to give everyone another 5 minutes or 7 minutes. I can do math. 7 minutes to show up. But if you want to put your name in the chat, and I'm going to mute myself. And yeah, I'll see you guys in 7 minutes. Get all your supplies together. We're playing today. Okay. Good morning, everybody. Happy Wednesday. We are moving into our last lab activity of the semester. So this semester we've been working on writing up 2 lab reports. The first one is that reaction time lab that we've kind of been dealing with for most of the semester. And today we're going to do the activity that we'll build our second lab report from. Next week we're also going to have our last literature discussion, and this paper is longer than the other papers we've done. So please make sure you give yourself time to accurately read it and get prepared for it. But I think it's a paper that you should find interesting. It's about vaccine development for COVID-19. So it's at least relevant to what we've all been talking about and thinking about and on everyone's mind. So we're going to end with that paper, and then we'll go into the last section of the class, the last third, where we'll have a workshop about finishing up our lab reports, and then we'll talk about some like life documents, right? So a resume, a CV, a personal statement, all of these things that I think are going to be useful for you guys that we're going to get practice working on. So what I want you to do is to make sure you have all of your supplies ready for lab 2. So lab 2, we're testing the efficacy of different types of masks that you have. So you need to have 3 different kinds of masks. Please make them as different as possible. Maybe you got a cloth mask, a disposable mask, a bandana, one of those like buffs, a scarf, an old t-shirt that you turned into a mask. You need all that stuff. And then we're going to do 3 different tests on them. So let me share my screen here with you guys. Awesome. So this is our class 9 agenda. So first, there's no like formal attendance quiz, but what I want you guys to put in the chat is and I'll save the chat as your attendance quiz, is a description of what mask you think is going to be the best. So as your little attendance record, tell me what mask that you have that you think is the best mask. Is it a cloth mask? Do you think a filtered mask? Do you think the disposable masks are going to be really good? A surgical mask? Oh, Kristen, you've got access to the good stuff, don't you? I haven't been able to find those for a while. Yeah, so do you have access to an N95? Are you extra fancy? N95, yeah. So let's make our hypothesis about what we think is going to be the best mask. N95. Do you guys actually have N95 masks to test, or you just think that those are the best? The mask I have, I think, is, yeah, the disposable mask. You do have one. Raquel, that's very fancy of you. Also hard to find. Okay, so while you guys hypothesize here about what masks you think are going to be the best, let's talk about the procedure that we're going to do. Okay, so we go through a little overview here, a purpose of the lab, thick cloth, triple layer. Yeah, triple layer. Okay, we're going to do 3 tests. Now, I'm in my office in Health Science Center right now. I'm not allowed to light a fire, so I didn't bring a candle. So I won't be able to show you this first test, but we're going to assume that you're able to do the first test. So the first test is the candle test. You're going to take a candle, you're going to light the candle, and then you're going to measure 3 inches away from the center of the candle, 6 inches, 12 inches, and 24 inches. You'll start at the furthest distance, so 24 inches, without your mask, and you'll see, can you blow the candle out? Then you'll move to the 12, 6, 3, etc. Then you'll repeat the whole process wearing mask 1, mask 2, mask 3, okay? At the bottom of this document is a Google Doc. So at the bottom of our class 9 page is a Google Doc that brings you here. What I want you to do is to fill this out. So put your name and your mass number, and we're going to give it a numerical score. So 0 means you were able to blow it out. There's 0 flame left. Or a 1 means the flame was still lit. Okay, so you're gonna do this for 3 inches, 6 inches, 12 inches, and 24 inches. Let's start with that one. So what I would like everyone to do is to light their candle and mark off their distances. And start with no mask. See if you can do it, okay? See if you can do it. I'm gonna stop sharing so I can be back here if you guys have any questions. Let me know. This is how we're gonna start off. Here. Okay, do I have everyone's hypotheses? I do, awesome, okay. So, light your candles, blow out your mask. Let me see if I need to create, I probably need to create a few more rows here. Let me just expand this. Amy mask 1, yes. So you're gonna measure it first with no mask. How good are you? And then with masks. If you also wanna put, so you're doing mask number, put how close you had to get with mask. So mask 0 will be the no mask situation. So right now, Amy, you wrote Amy/mask 1. Also make a line for Amy, mask nothing, exactly. And so everyone is gonna do that with their names. And again, 0 means you blew that candle out, and 1 means it was still lit. Starting at 24, get closer and closer and closer and closer. Awesome. Great, guys. We're just gonna build this data table together as we play with fire this morning. I was sternly reminded that I am not supposed to light fire in my office, which is, you know, totally fine. I get it. Great. Okay. I think I might need to add even a few more. Uh-oh. Edit undo. I'm messing around here. Let me add some more rows. Okay. Okay. So Kristen has very strong lungs and was able to blow out her candle from 24 inches. Good job, Kristen. I, as an asthmatic, was not that successful, but that's okay. That's okay. Nine times 3. Oh, it's 36. So while you guys fill that out, okay. So Kristen, her first mask, she had to get to 3 inches to blow that out. Ify blew it out at 6 inches away. Okay, okay. While you guys do that, I'm gonna add more rows to these ones because I recognize my error here. Okay. Okay. Great. Great. Okay. So remember, 1 means it was still lit and 0 means you blew it out. So Kylie, you only were able to blow it out from 24 inches away, but not from 3 inches away? Or is that mixed up?
I messed up.
That's okay. I figured. So the number, think about the number as like the amount of fire, right? 0 being blown out, no fire. 1 being a full amount of fire. We're giving it a little binary code here. Okay. Let's see how people are doing. Awesome job. Okay, so Erm was able to blow out his candle from 12 inches. Awesome. Kel's first mask, fireproof, or candle blowing out proof. Awesome. Okay. Awesome. Okay, so Amy's first and second masks, she had to get to 3 inches before her candle went out. Awesome. Raquel, both of her masks, super strong. Okay, great. Okay. Then it's 2 masks. Awesome. Awesome. Great. Haley's first mask is also super strong. Kylie's mask. Okay. Let's give everyone another few minutes here. Okay. Kayla's masks going, yeah, putting them down there. Awesome. Awesome. Okay. Haley's on her 3rd mask. Kayla's putting in her data. Great job, great job. Looks like most other people are finishing up. Awesome. That's 3. Okay. Michaela also has some strong masks there. Okay. Great. So let's talk about it. Let's talk about the data. So let me pull up a little whiteboard here. Let's pull up a little whiteboard. So if we were to graph this data, right? So let's put a y-axis, and then let's put in an x-axis. So let's think about how we are going to graph this data. How are we going to graph this data? Kylie, what would we be putting on the y-axis? What do you think?
The dependent variable goes on the x-axis, and then the y-axis is the independent variable? Or do I have that backwards?
Yeah.
Backwards.
Yeah.
Okay.
So the independent variable we're putting on our x-axis here. And so the independent variable, let's start with the dependent variable. So what are we measuring, Amy? What are we measuring that will go on the y-axis?
The length that the candle is away from us.
Close. what is changing, what we're measuring is whether it's lit or not, right? So candle litness is what we're putting on. If I can move this, it would be great. Well, I can't. Okay, so candle litness is what we're putting on the y-axis, and that's going from a 0 to a 1. On the x-axis, we're putting distance away in inches, right? And so if we have down here 3, 6, 12, 24, we would expect when we don't have a mask on, so we'll start with a black line, right, for no mask. Maybe at 3 inches, it's down here at 0. At 6 inches, it's down here. And then it goes up to 12 and 24, right? So the candle was still lit at 12 inches away, at 24 inches away, but at 3 inches away and 6 inches away, we were able to blow it out. Does everyone follow along so far? Okay. Now, if we have a good mask, Kristen, would we expect the curve to be shifted to the left or to the right?
To the right.
If we put it to the right, it's also down here at blown out at 12 and 24. We would expect it to be shifted to the left, right? A perfect mask we would not be able to blow a candle out at 3, at 6, at 12, and at 24. Does that make sense to everyone? A perfect candle, or perfect mask, we would not be able to blow out the candle, right? It would be so thick and so protective that we're blowing and blowing and blowing, and that was not the case, right, for some people. This would be a perfect mask. Now, if our mask was not very good, we would expect it to be, let's change it to a different color. If our mask was not as good, we would expect it to follow that same line as no mask, right? A bad mask is the same as not wearing a mask at all. Okay, so with that being said, Raquel, you had some really good masks. What were your masks made of that you tried that performed so well?
One was the UNCP mask.
Oh, good. Okay.
Yes. The other one was an N95.
An N95, okay.
And the other one was the surgical mask, but the ones that are disposable.
Got it.
Disposable,
So Raquel tried a lot of different types of masks, found that for most of them, they're very good masks. Okay, let's try the second test. I'm gonna save this little whiteboard here. Let's go back to our Google page here, guys. So the next test that we're going to do, so that was a candle test, is the smell test. So I'm gonna take my smelliness, it's gonna be the coffee. Okay, so what you're gonna do is first, without your mask, you're gonna see if you can smell the substance, the coffee. Now what I want you to do is a science smell. So you're gonna hold it to your nose, and then you're gonna gently waft the odorant into your face. You're not going to huff the odorant, right? So gently waft it and rate it on a scale of 0 to 5. 0 being no smell at all, and a 5 being this is the strongest smell I've ever smelled, right? So you're gonna do it with no mask, do it once, and then for this one, we're gonna replicate it. So do it once, okay? Move away, whew, breathe, breathe. Do it again. Walk away, whew. Do it again. Walk away. Okay, so for each condition, we're gonna do 3 replicates. So you're going to smell it without your mask 3 times, then put on your first mask, smell it 3 times, put on your second mask, smell it 3 times, put on your third mask, smell it 3 times, and let's see if our masks are able to block the chemicals that signal smell, those odorant chemicals. Okay, and so you're gonna put your data down here on the smell test. Great. How good are your masks? And again, a good mask should block all those smells. Let's see how good our masks are. And while you do that, I'm going to drink my odorant, which is coffee. Okay. Great. Yeah, so there's going to be a little bit of variability, right? That's why we're going to do it 3 times. There is going to be a little bit of variability. Awesome. Awesome job, guys. So we're smelling, pausing for a second. We're smelling again, pausing. We're smelling a 3rd time. And then we're putting on our first mask, doing that same thing. And you want to make sure that you hold the smelly thing kind of in the same position. You don't want to have one where you're holding it like right up to your face and then another one where it's like way over here, right? You want to try and keep those conditions similar. Okay. Great. Awesome. Awesome. Okay. Awesome. Most people are finishing up their smell tests. Most people are finishing up their smell tests. Let's give everyone another few minutes here. Great. Okay. So it looks like Haley's on our last one. Kristen's putting in her last bit of data. Okay. Awesome. Awesome job, guys. Okay. I'm going to pull up that whiteboard again and let's talk about it. Let's talk about what we observed here. So now if this is, I'm going to clear that first drawing. Let's make another graph here. Okay. So we're making another graph. Okay, so Michaela, what's gonna go on our y-axis this time? You're able to unmute yourself. Okay, I know you sometimes have trouble with your audio. Do you wanna put in the chat, if you're having trouble with your audio, what goes on our x-axis? And Amy, do you wanna tell us what would go on our y-axis here?
Would the y-axis be like the smell of whatever we're smelling?
Smelliness, right? So we're gonna put smelliness on the y-axis. And for this, because we did it 3 times, we can do mean smelliness, right? We can do mean smelliness. And on our x-axis, we can do what? What's our x? Distance. Distance was for the last one because we changed the distance. Here, we're going to do mask number, right? So on our first graph, when we were talking about the candle test, we wanted to use an XY scatter plot because both our y-axis variable and our x-axis variable were numbers, right? We were talking about numerical values for distance and for candle litness, right? How lit was our candle. Here, the x-axis category is a description, a descriptive category. So we're gonna have, for example, no mask, and then mask 1, mask 2, mask 3. Okay, we're gonna have these descriptions here. And so what we wanna do instead of an XY scatter plot is a bar graph. We're gonna do a bar graph here. So for no mask, for this one, maybe it was like all the way up to a 5, right? Let's put a little text bar here, 5. Okay, so you were really able to smell your smelliness, smell your substance, right? If the mask worked, we would expect it to be a much smaller bar, right? So maybe this one's a little bit bigger, and then this one is even worse. So, Efi, which of these masks, according to the graph, is the best mask? Mask 1, 2, or 3, according to this graph right here?
3.
1.
1.
1 is the best because we want a mask that blocks all of the smells. Smell is the sense of olfaction, and it works by little chemicals in the air binding to receptors in our nose. If the mask is a good mask, it is blocking all of those chemicals from reaching our nose. And so we want a very low score for mean smelliness. Does everyone see that? Okay, so for this graph, we can calculate a mean, and the other super fun thing I know you guys are excited about, we can also put error bars on these graphs, right? Because we can calculate standard deviation because you did it 3 times. How exciting is that gonna be? I know, we're all thrilled about it, okay? So mask 1 would be a really good mask, mask 2 would be a medium mask, and mask 3 would be not as good, okay? The last test we're not gonna do, or I'm not gonna make you all do right now, and that's because it requires a lot of time. So what you're gonna do for that last one, let me save this whiteboard here. For the last test is the water test. So you're gonna take your mask, and I'm not gonna do it because I have to wear this mask, and you're going to fill it with water, not until it overflows, but until there's a good amount of water, and then you're gonna hang it. And you're gonna calculate the amount of time it takes for water to appear on the bottom and start to drip out. You will stop yourself at 5 minutes. So for an N95 mask and a super good mask, no water is gonna get through. You're just gonna nothing's gonna happen. So what I want you guys to do is to time how long it takes. If it reaches 5 minutes, just put 5, that's kind of the maximum. So you're gonna do that on your own time. I'm not gonna make everyone sit here for all of your mask water drippings, okay? So let's go back, let me go back to Canvas one last time here. Okay, so that is what we've been working on. Let's go back and see what else you guys have going on. So you're going to, let me scroll down here. You're going to complete the lab activity and put your data into that Google Doc. And then you're gonna watch a video about writing a discussion section. And your assignment is to add a discussion to the methods and results you have for the reaction time lab. And then for this lab that we just did, the COVID masks lab, you're gonna put methods, results, discussion, and the pre-lab questions all together. So you're building on that. And then next week, you'll have the peer review of the reaction time lab, and then eventually you have the peer review of our COVID mask lab. And the week after, again, is our last journal club, okay? And next week, you'll be working on full drafts of these 2 lab reports. So again, we're in class 9 agenda. We've been working on this mask lab. It has, if you scroll down, the protocol again for the water test, and then some questions I want you guys to answer where it says you'll be turning in methods, results, discussion, and pre-lab questions. So these questions about identifying the dependent and independent variable, excuse me, for each of the different experiments, the expected relationship, respiratory droplets, citations, etc. Okay, I'm gonna leave you guys to play with water. Are there any questions at this time?
Okay, so you said for the water activity, what
Yeah.
we be doing is pouring water like on the mask?
Yeah, on the mask, yeah, where your face goes. Mhm.
Okay.
So this is my mask. I'm
Mhm.
gonna pour the water, and I'm not gonna do it because I have to wear this one. You're gonna pour the water here, and then you're just gonna hold it like this. So this part has water in it. Not so much water that it like pours over the sides, but you're
Mhm.
trying to see how long it takes for water droplets to appear on the bottom.
Oh, okay.
Does that
Okay.
make sense?
Mhm.
Okay. Any other questions about what we're doing? Okay. With that, I'll leave you guys. Get to work watering your masks, and I'll see you next week.
Okay, have a great day.
Thank you. You too.
So are we turning in 3 graphs?
Yeah. Mm-hmm. A graph for each protocol. Mm-hmm. Mm-hmm.
For how long do we have to time the water in the mask?
Maximum 5 minutes.
Okay.
Mm-hmm.
So we have to wait 5 minutes for each?
Yeah.
Okay. And also for this week's peer review, I can see my peers' assignment.
Okay, I'll push another notification.
Okay, perfect. Thank you.
You're welcome. Everyone else good? Kylie, you good? Okay. Raquel, I'll push that notification for you now.
Okay, thank you.
You're welcome.